Adjuvants are a really important additional ingredient to some vaccines. And I say some vaccines, really important to know that adjuvants are not found in all vaccines. We only use adjuvants in a vaccine when the antigen isn't great at eliciting an immune response, or at least a memory immune response on its own. One example is in the DTaP vaccine, which does have an adjuvant in it. So if you remember back to a few weeks ago when we talked about DTaP, this vaccine actually contains the toxoid. So the antigen is the toxoid, which is the inactivated form of the toxin. So for example, tetanus produces a toxin, and that's what creates all the symptoms of people with tetanus. And then in the lab, we created the inactivated version of the toxin, which is the toxoid, and that's what's found in the DTaP vaccine. And for some reason, which we don't exactly know why, this tetanus toxoid is not great at eliciting a memory response. So that's why we need to add in another ingredient to really boost that long-term memory. And this is where the adjuvant comes in. So when we add in the adjuvant, it kickstarts the innate immunity so that when we have the antigen plus the adjuvant together, we have long-lasting or longer-lasting memory response. Now, it's still not a lifelong memory response, so for DTaP, we need to get a boost every 10 years. And we need to get it because the memory response starts to wane. It's still pretty good though, 10 years isn't that bad. So a few examples that I put up here to know are LPS, which if you remember from one of our first lectures is a PAMP found on bacteria cell walls. The other, and this is the most common example, is called aluminum salt. And if you notice that it's a salt, so it's not actually like aluminum foil that we're injecting into your body, but it's the salt form. And we actually don't know a lot about how aluminum salt works to elicit an innate immune response and then in turn a memory response. We just know that it works. Adjuvants are actually a big line of research because many of them we don't know exactly how they work, we just know that they do. But there's a lot of research going into figuring out the how. There's also new research going into fine-tuning adjuvants so that by using a particular adjuvant we can get a specific immune response. This would be really great because I said in the previous video that the licensed vaccines on the market today are great at eliciting antibodies and long-term B cells, but they're not great at eliciting T cells. So we're working on adjuvants that could specifically elicit a T cell response, specifically a Th1 response or a Th2 response. So this is something that is actively being researched and worked on. But remember, whenever we change one component of a vaccine, it then has to go through a very long and expensive, rigorous process of safety testing. So we can't just change vaccine ingredients suddenly. They actually have to go through like a decades-long process of testing first. So that's why it's really important that we get Congress to fund this kind of research, because whatever we change is going to take a really long time to get to market. So adjuvants, they're there to kickstart the innate immune response when an antigen by itself cannot elicit a memory response. So DTaP, one example.